All right, part 2 of the electric charge WebQuest video. I apologize, this has to be 2 parts, but the website that I'm using doesn't allow it to be more than 15 minutes. And when I timed it, I was at like 16 or 17. So I apologize, just a couple minutes more. We left off in our previous notes talking about what causes static electricity. Just to kind of remind you, it's the buildup of electric charges. That means that there's more protons on an object or more electrons on an object. I'm going to write that on the side here. More protons or more electrons on an object. In this part of the video, I'm going to explain how some objects themselves might have more or less protons or electrons or whatever that looks like. So the best way to kind of observe this is through one of the online FETs that you did in your WebQuest, and that's the next part that we're going to go over to. It's the simulation that had the balloons in it, the balloon and the sweater, really. Right when you open that online simulator, if you look at the balloon, if you count both types of charges, you should have same number of protons and electrons, okay? If you have the same number of positive protons and negative electrons, that means that you have a neutral atom. The positive protons cancel out the negative electrons. You have the same number of each, they all cancel out. The total overall charge of the object would then be neutral. There is no charge. If you have more protons or more electrons on an object, that would tell you if the object itself is positive or negative. So when you click and drag the balloon and rub it against the sweater, that friction is physically peeling electrons away from the sweater. Okay, I'm kind of getting ahead of myself here. Number 19, how did the balloon get charged? It literally took electrons off of the sweater. If we kind of go back to what an atom looks like, you have the nucleus, and then the electrons are on the outer rings. So if you have like an electron on the outermost layer, it's held very loosely, if you remember our conversations. So that's what physically moves off of the atom and helps it become charged. And if you have enough of that, it's going to make the overall object charged. So you have positive protons in the middle here, neutrons, blah, blah, blah. So at this point, after you've done this, and once again, as I pushed with the last video, if I'm talking a foreign language because it's been so long or you were absent and didn't see it or don't remember it, please go back and just quickly take a minute and just open this application, open this simulator, drag the balloon, rub it on the sweater so you can see what I'm talking about. The balloon itself will take electrons away from the sweater. That means that the balloon is becoming negative because now it has more electrons. If it has more electrons that are negative, that makes the overall charge of the balloon negative. Okay. Where did it came from? The electrons came from the sweater, so that's where it's getting its charge from. Moving on to the next page, it's kind of talking about the opposite here. So what happened to the charge of the sweater? Well, the sweater became positive, and that's because it lost electrons. Electrons moved off of the sweater onto the balloon, and now the sweater is left with more protons. I'm going to add a note on the side here that says only electrons move. Once again, the protons in the middle of the nucleus cannot move. It's the outermost electrons that move. Only electrons move because the sweater has more protons left behind. That's what's making it positive. Okay. When you bring the balloon into the middle, it should move back towards the sweater. That's because the sweater now has a positive charge. The balloon has a negative charge, and if you remember in the previous video what those forces do to each other, well, if they're opposites, they are going to attract. And you're going to get a force field built between the two objects as long as they're within the field of each other. If you look at the wall itself is neutral. Once again, it starts off with the same number of positive protons as negative electrons. That means that they cancel each other out, and that's what makes it neutral. However, if you have the negatively charged balloon and you bring it in contact with the wall, you'll notice that the balloon can actually stick to the wall. And that's because the negative charges in the wall are repelled away from the balloon because the balloon is also negative. So if you remember, oh my gosh, this is the worst balloon I've ever drawn. This is my balloon. If you bring it towards a wall that has kind of a neutral charge, what's going to happen is, let me get a different color here, these negative charges right towards where the balloon is are going to get moved away because they're repelled from the balloon. I'm sorry if you can't read that. But the negative charges in the balloon are repelling these negative charges right by that area of the wall. Remember that if they're the same charge, whether they're both negative or both positive, they're going to repel from each other. And that is how that portion of the wall becomes positive. It's because the negative charges are repelled away from the balloon. Because now you have an overall positive charge right by the balloon, that creates an attractive force. You have a positively charged area and then a negatively charged balloon, you're getting that attractive force. Remember, opposites attract. Looking at some of the rest of the key things here, it has you reset the button, move the wall, remove to the wall. It's one slip. Okay, so in this portion, you were just slightly rubbing the balloon against the sweater, and then in number 28, you're rubbing the balloon a lot more against the sweater. And that affects the rate at which it moves back towards the sweater. So if you only charge the balloon a little bit and only give it a little bit of a charge, it's going to move a little bit more slowly. And if you give it more of a charge, it's going to move more quickly. That has to do with the strength of the electric field. So we talked about in the previous video how distance affects the strength of electric field. It's also the amount of charges that affects the strength of a field. And that also goes with goal 2A. So there's two things that affect the strength of fields. As we talked about in the previous video, the distance between the charged objects affects the strength. It's also the number of charges built up on an object that affects the strength of it. Built up on an object. So if an object has only a little charge versus a larger charge, that can affect how big the field is and how much it can affect other things around it. So that's goal 2A again, once again in your study guide. More charges create a stronger field. All right, moving on. I'm just gonna quickly go through some of these. I'm just going to scroll through the rest of the video, and if you want to look at some of these answers, you can pause it. A lot of it's the same ideas that I've already kind of discussed here. It's just now you're using two balloons. And then if they have opposite charges, remember the opposites will attract, and so that's what's causing kind of an attraction between those two objects. And then in 33, if the balloons are both negatively charged, keep in mind that because they both have the same charge, they're going to repel away from each other. So once again, very similar to some of the things we've talked about. I'm just going to scroll down and show you the answers to the last part of this. I really wanted to just really discuss some of those key things with you. this last part just kind of goes over materials and how some materials give up electrons more than others. So we talked about conductors and insulators. Some tend to give up electrons, some tend to attract electrons. It really just depends on the material. And so this kind of investigated what some of those things did in number 34. In 35, I already kind of talked about lightning and how lightning works. It's just a very large electric spark that jumps from cloud to cloud. You'll also watch another video about lightning, and you'll watch another video about Van de Graaffs as well. So I'm not as worried about those, but I will show it so that you can kind of check over the answers that you have for this. Please keep in mind, if you have questions, let me know so I can help you guys through this stuff. Sorry we can't do this in class personally, but we'll do our best. See you guys.